an Owasp top 10 driven survey on web application protection methods. This work is presented by Wasim bin Faraj, Omar Sheikh Ruhu, Muaz Krishan, myself Habib Hamam, and Abdul Wahid Derhab. Owasp stands for Open Web Application Security Project. Open Web Application Security Project. It is an online community that produces free available articles, methodologies, documentation, tools, and technologies in the field of web application security. The roadmap in this presentation: problem statement, motivation, Owasp top 10 project, web attacks, countermeasures, current WAFs. WAF stands for Web Application Firewalls, model-based testing, and formal methods. At the end, some conclusions. Problem statement: the number of web applications is growing exponentially. The number of attackers is continuously growing, and their attack techniques are becoming increasingly sophisticated and dangerous. The security administrators usually deploy WAFs. WAFs are often trivial protection methods. There is a large gap between the state-of-the-art web protection methods and those employed by the existing WAFs. What is the motivation behind that? The paper tries to narrow down this gap by identifying the most severe web attacks as well as the appropriate countermeasures against each attack.
Injection. It includes command and SQL injection. Malicious people can remotely run codes that execute unauthorized tasks. Broken authentication and session management. It is most commonly performed through social engineering and password attacks. Attacks include generating complex passwords and enabling two-factor authentication whenever possible. Cross-site scripting. It consists in web-based attacks executing malicious instructions. These instructions include website defacement, stolen login credentials, stolen sessions, and redirecting users to malicious websites. Insecure direct object references. Most web applications use simple IDs to reference objects. Example, a user in a database will usually be referred to via the user ID. The same user ID is the primary key to the database column containing user information and is generated automatically. The database key generation algorithm is very simple. It usually uses the next available integer. The same database ID generation mechanisms are used for all other types of database records. This way of operating is common, but not recommended because it could enable the attacker to enumerate all users. Security misconfiguration. Giving unauthorized access because of administrator error and quite often laziness. Sensitive data exposure. It includes the unauthorized access as well as the user of sensitive data. Data should be encrypted to avoid its unauthorized use when lost or stolen. Data should be protected. Data should be backed up. Missing function-level access control. The authentication check in sensitive request handlers is insufficient or non-existent. Example 1. An unauthorized user being able to access a URL that contains any sensitive information or exposes functionality intended only for authorized users. Example 2. Hiding a feature from the user, but allowing the request if the user is able to figure out how to conduct it. Cross-site request forgery. It is an attack that forces an end user to execute unwanted actions on a web application in which they're currently authenticated, using components with known vulnerabilities. Well-known vulnerabilities in protocols and codes are often exploited to attack applications and systems. Best fight: keep devices and applications patched and up to date. Invalidated redirects and forwards. They occur when an attacker is able to redirect a user to an untrusted site when the user visits a link located on a trusted website. This vulnerability is also often called open redirect.
Let us go now to countermeasures against these attacks. First of all, Countermeasures against injection attacks. There are a lot of works. Shahrayar and Zulkarnain, they proposed to compute the entropy of every query included in the program source code before the deployment. Then they compute again in the entropy of each invoked SQL query to detect if there is any change in the measured entropy. Another work, Owasp proposed a WAF that is based on artificial neural network, ANN, to avoid SQL injection attacks. Third work, Mamadan and co-authors proposed semantic comparison between two syntax trees of a query during training and runtime. If the two trees are not similar, the query is classified as malicious. To name another example, the work of Halfond and co-authors. The Owasp uses positive tainting to identify and track trusted data instead of tainting untrusted data in the traditional negative tainting approach. Let us go now to countermeasures against broken authentication and session management. Measures are proposed against session hijacking attacks. In this case, the web server binds a user's session to a fixed IP address and then discards any requests coming from a distinct IP address. This is ineffective in NAT. Another work, Niki Forakis and co-authors proposed to track user browser fingerprint. What is a browser fingerprint? It consists of numerous characteristics of the user browser. Any modification of the user browser fingerprint might represent an attacker stealing a session. Third work, Adida suggests a session lock. The author adds integrity checks to every client request based on a secret shared with the server. If a session identifier is stolen, a valid request cannot be computed since the value of the secret is unknown. Another author, Da Costa, using one-time cookies, proposed to replace the static session identifier with disposable tokens per request. Another work, Jones and co-authors use chains of nested hash-based message authentication codes, abbreviated by HMAC. These codes are constructed from a shared secret and a chain of messages, and see which countermeasures are proposed. Countermeasures against XSS attacks. A first solution, access XSS. Here we propose a user input validation to enforce the security. Validation can use defines trusted origins that the browser is allowed to download resources from them. Another work, Wurzinger and co-authors present a framework containing a reverse proxy intercepting the returned HTML messages first, then using an altered web browser to locate vulnerable scripts. Shahrayar and co-authors propose to use a callback labeler divergence, abbreviated by KLD. So they proposed to use KLD measures to provide a proxy level detection methodology. The authors suggests to proceed to the tokenization of the considered script code into unique elements and calculate the probabilities of their occurrences in order to construct two sets P and Q. The set P includes a legitimate JavaScript code available in the application page, whereas the set Q includes observed JavaScript code available in the response page. Then KLD computes the distance separating these two proposed probability distributions. An XSS attack is detected in case of a significant divergence between the two sets. Let us now handle two attacks at once. Countermeasures against insecure direct object references and missing function level access control. To secure the access of the resources and the utilization of internal functions of a web application, most of security systems have used access control mechanisms. For instance, in the role-based access control, abbreviated by RBAC or RBAC, programmers control objects by permissions, assign permissions to roles and assign roles to users. Permission authorizes a user for a role in a given session. Cisco ACE Web Application Firewall uses role-based access control, RBAC again, to define the administration roles of the WAF itself. In other words, Park and co-authors proposed an implementation of RBAC with role hierarchies of the web by secure cookies. The user's role information is injected in a set of secure cookies and transmitted to the corresponding web servers. In order to verify the cookies, they use PGP, which stands for Pretty Good Privacy. So they use PGP to define cookie verification procedures. Let us take a last one. Ardania proposed a work that is based on the extensible access control markup language, abbreviated by XACML, which belongs to the class of access control languages. Another attack: countermeasures against sensitive data exposure. Information leakage. How to handle this attack? It is the role of the developer and only the developer who can improve the security by paying attention to what he leaves in the code and to handle in a secure way the errors that can occur. Now, transmission attacks. This kind of attacks is mainly avoided by a strong encryption mechanism, and we do not know approach used in WAFs. Let us take a last attack: database thefts. To deal with this attack, cryptography is a key solution, together with a good security policy to access database. Doshi and Trivedi, two authors, proposed a set of dynamic database security policies as a solution of this kind of attacks. The famous CSRF attack. Owasp developed a project called CSRF Guard, means a guard against this kind of attack. So this guard is a library that implements a variant of the synchronizer token pattern to minimize the risk of CSRF attacks. Jovanovic and co-authors defined a server-side proxy named NoForg, which could be plugged into the considered system to discover and avoid CSRF attacks, and it is transparent to users and PHP web applications. Countermeasures against invalidated redirects. Scott and Sharp categorized the phishing countermeasures into 5 categories. Category number 1, blacklist-based category. It consists in building a repository of discovered phishing URLs, which should be updated regularly. The most representative works under this category are the Google Safe Browsing API, also FINET, which predicts the phishing URLs based on the known phishing URLs. Another work, third one, AIWL, which keeps a list of trusted login user interfaces. So this category number 1, namely blacklist-based category, offers good true positive rates but suffers from bad false positive rates. Second category, whitelist based category. This one could help decrease the false positive rates and improve the detection of zero-day attacks, but their maintenance is very complex. Heuristic based approach or category. It inspects real-time payload in order to detect suspicious traffic. Number 4, visual similarity based category. This category visually compares a suspected phishing page with the legitimate one. The goal is to determine whether the two pages suspiciously similar. The last category, the machine learning based category. This category gives good result for zero-day phishing attacks, but their false positive rate is high. This category is time consuming and is usually implemented in the browser. Some WAFs, the Actronics WebNight, Mod Security, Dot Defender, Imperva, SecureSphere, Barracuda, Azure Web Application Firewall. All of them use not complicated protection methods. In conclusion, let us say we presented here a survey about web applications, vulnerabilities, and attacks according to the project Owasp. We presented a set of up-to-date countermeasures on the server side. Unfortunately, current WAFs use trivial protection methods and need close look and more attention. Finally, it is clear that there is a big gap between cited countermeasures and current WAFs. I hope that this work will be beneficial for some of you, and thank you for your attention.